Oh, and we're live. So this is Data Science Deployed, episode 9, and we are going to be talking about linked data. This week, it's just me, Jillian, and Donny. And Donny here is the brains behind the operation in the linked data. So can you tell us a little bit about like what is linked data, how you came to know about it, why we should care about it, all that kind of thing? Give us the explain like I'm five intro. Give me the explain like I'm five intro.
Sure, I will attempt that. Yeah, so linked data. The two components of that are linked and data. So data, we won't get into too much, but it's essentially it's stuff that can help you model things, explain things, predict things. Uh, Numbers, different data types, data, and specifically the focus here on linked data is structured data. So people will talk about unstructured data like documents that you might mine or something, versus things that have more structure like key value pairs in a document or rows in a table with columns. So it's more about the structured data, and the linked part comes from uh, being able to uh, connect things through links, specifically hyperlinks. So this is really based on um, the web, the World Wide Web, and protocols like the hypertext transfer protocol (HTTP), and like where you kind of get a web link that you can paste in your browser window or curl on the command line or something. Um, and so that's what these links are about. And so like, how do you link data sets? Well, you might have like, two tables. And if you're familiar with say, SQL or something, you might have this implicit linking where you might have, one table has an ID, and another table has a, uh, you, you know, uh, part ID that implicitly, when you're looking at that as a human, you can say like, oh, okay, I think this should be the same thing as an ID, something in the ID column of the parts table, because it has the column part ID here. And so that's sort of a link, but it's implicit. You kind of have to read that and know, I guess, English in this case, or I mean, you might have like a something a bit more explicit in SQL, where you kind of have this foreign key relationship and you kind of do that link. But what linked data really says is, okay, we can have this ad hoc way of teaching people like what a link means, or like introducing these things and call it foreign key or whatever, or we can build on top of the web and just have, instead of some string ID in that field, we can have a hyperlink, an HTTP URL as the value of that cell in that table, and like that literally will link to the other thing. And so we can compare them by equality, and they're global identifiers. So we can go through the HTTP protocol, HTTP:// and use the domain name system or the IP address or whatever, and we actually have a link to that other thing. And so linked data is fundamentally about that. It's about embedding links as the values of things in your data, so that given one data set, you can find more about that data set, not only the values but the terminology. So even effectively, the equivalent of column names or row names are themselves URLs. So like, I want to find more about what this field means, so you can click on that essentially and get like, oh, this is what this is. Here's a human description of it. Here's, it should be an integer, it should be greater than 5, or whatever you want to do. But that's sort of the fundamental idea of linked data, is you have all these data sets and they actually have links in them, and they're comprised of links. And there are some techniques about how to make things a bit less verbose and human readable and friendly, where you kind of don't have to look at a bunch of long links in your entire data set. You can look at things that are shorter and use these like little prefixes and that sort of thing. But fundamentally, when you look at a data set that's in the linked data format, everything, all parts of it are kind of a portal to the rest of the web of data, and you can sort of link out to other data sets and find out more about stuff. So that's the fundamental idea of linked data. Again, specifically building on top of web technology, HTTP links.
Yeah, I think this is all really interesting because it's this kind of idea that's been spinning around for a while that like data is such an integral part of software for the most part. And so if you can, you have data, you need a way to describe the data, and then on top of that, you can build something like an API. And I think more and more everybody's kind of coming to the realization that there needs to be some kind of standard there, so that like you can actually talk to other people. It shouldn't just be or hopefully it shouldn't just be like a subject matter expert who knows what the materials or the genes or the proteins or whatever are, but instead you can have this kind of self-documenting data structure and, and throw it out to the world. So what kind of technologies do you use to do something like to use this sort of linked data approach?
I use a lot of Python personally. I really like this library called RDF-lib to work with this stuff. So it stands for RDF library, and RDF in turn stands for Resource Description Framework, which is the data model that underlies linked data. So the R in URL is that same thing. Universal resource, uniform resource locator. So resource is this thing, and how you describe these different resources. This library helps with that because you can essentially, manage data sets. If you find an RDF file online, you can fetch it and import it into a graph. It uses the different things around this ecosystem. Like there's a nice query language for querying these graphs, and there's a built-in engine in RDF-lib in order to do that. There are various helpers to get data in from various formats and out to various formats. So for example, dealing with JSON and dealing with other things. I like the RDF-lib tool. I also tend to store a lot of things in JSON, so I'll use MongoDB when I want to use document-oriented search for that sort of thing. There's another nice library called PyLD, which implements a JSON LD processor, which is great if I have a graph of linked data and I want to convert it and frame it into documents, or if I want to compact things to not have to look at the long URLs all the time. That's a nice library. It includes a lot of built-in namespaces. So this is a primary way by which you can communicate things like schema and meaning in RDF. So unlike say SQL, where you might have like a table definition with all the columns, you might have some URL namespace that has a bunch of terms in it, and so the terms are kind of the last part of the URL. And RDF-lib, as well as other tools, will have a bunch of these built-in namespaces that help you define things. So that it's one of the nice little tooling sets that I like for dealing with that.
Cool. Well, so you're talking about linked data, and I think you talked a little bit about nodes and graphs. So how does this compare to graph data, or I suppose specifically technologies like Neo4j, which I only sort of briefly know about because I know it's been picked up quite a bit by the bioinformatics community as a way to describe biological data. Because I know, at least in biology, there's sort of always been this tug of war between the scientists and the software people, where the scientists try to describe data, and it's very difficult to get it to fit into sort of this like tabular relational database structure, and sort of they go back and forth and back and forth and back and forth. And it seems like, at least for now, I think sort of describing everything as graph data or maybe linked data is winning the day. So how do these things compare? Are they the same? How different are they? Can you kind of communicate one schema to the other, or not so much?
Yeah, they definitely have a lot of similarities. So one of the things that you pointed out, which is great in terms of communicating with scientists, domain experts, is there are these different levels of data modeling. There's being able to model something at the conceptual level, and a lot of times for people that will take the form of graphs visually. Like at the conceptual level, people might go up to a whiteboard and like start drawing, circles and arrows, and they'll
Mind
essentially.
maps are my favorite way to brainstorm and brain dump it. Now that you bring that up, yeah, I do think it's a very just sort of natural human way to think, is to think in that sort of data structure.
Right, and so people have this conceptual model in their head of what it looks like, but then how do you actually get a computer to help you out with that and actually like represent information and draw valid conclusions from the premises and the facts of the system? And so often your logical model will look a lot different than your conceptual model. So in the case of SQL, your logical model will be like, oh, we have a bunch of tables with columns and constraints on the columns, and it's not the same. It doesn't look like the thing on the whiteboard. The logical model uh, of the computation, the execution looks a lot different than the conceptual model. And then even downstream of the logical model, the physical model on disk, how things are stored on disk with like, B trees and different ways of like actually representing the tables and executing those is even further from like this conceptual model. Whereas something like the labeled property graph paradigm of something like Neo4j or the semantic graph paradigm of things like linked data, they're both more aligned with this conceptual model of a graph, and they actually help bridge it down. So like not only is that conceptual model, but also the actual logical model, how the database is working and how things are physically implemented, are a lot closer to the conceptual model. So that's one of the advantages for both of these technologies is kind of how things are actually implemented when people need to debug how things actually look is a little bit closer to how they actually think about the problem, as opposed to how someone needs to translate the computer to think about it. And there are a variety of reasons why that's been better nowadays. Faster compute, easier storage, faster on disk stuff. But essentially, they're very good like that. So that's how they both contribute. Now, in terms of how they're different, the Neo4j, the labeled property graph model, it definitely has nodes and edges and connections between them. What it allows you to do is it allows you to label any of those things. So like a node in a graph, you can have arbitrary key value pairs of that node that aren't necessarily part of the graph. Like they're not edges. They're kind of just like a sticky note that you can hang on top of the node. And there's also like a sticky note that you can hang on top of any edge. So any edge between two things, you can put a sticky note and have key value pairs that are associated with that edge. Like, oh, this edge was created by Jillian on this date. I have this much confidence in it. And the same thing with all the nodes. And so that's it's nice conceptually for people, and you can certainly navigate that because it goes beyond a graph a little bit. You sort of have your maybe your graph of actual connections that you can traverse, but as you're traversing things, you can also go to each of those things and be like, well, what's on the sticky note here? And so you kind of store a lot of stuff. So that's kind of how that model works. And there's less emphasis on being able to find things unambiguously and persist things. So there's not the same cultural discipline in that world on using URLs as name for things, using persistent IDs and names for things. It's kind of do whatever you think is nice. It's almost like taking the whiteboard directly on disk and searching it. With the semantic graph approach, you don't get these sticky notes all over because we really want it to be a graph. And that doesn't mean you can't annotate things. It's just if you have a note, rather than having a sticky note with key value pairs, that would be part of your graph. So your key value pairs would actually be additional edges, and the values would be nodes. So you'd actually be creating a more comprehensive graph, and you'd be able to navigate it. And so I think the power is similar in both of them. It's kind of, do you want to have everything be in the graph, or do you want to be able to have like these sticky notes all around? And there's a lot of power in being able to like have everything in the graph, because you sort of don't have to leap out and sort of work in a different mode of like, oh, and I also have these various notes laying around. So there are strengths and advantages, and I think also these worlds are converging a little bit. So there's this standard called RDF star, which kind of extends the semantic model a little bit to make it a little bit more syntactically easier for people to do the equivalent of these sticky notes, but still have them be part of the graph. And I know things like Neo4j allow import of RDF. And so these kinds of things are converging a little bit. But I think the fundamental difference is that with the semantic graph, you want everything to be in the graph, and you want everything to mean something definite in order to facilitate data integration. You really want to be able to have everything as graphs, so that you can take a couple of graphs that other people have developed and sort of merge them together by like linking them like Legos. If these two nodes have the same URL, then they're the same thing, and then their edges can be, edges in the new graph. Whereas if you have this kind of graph with like sticky notes laid on top, you're kind of like, well, I don't know if I'm talking about the same thing here. So if you have a closed world, and you don't expect to, pull in any data from someone who you weren't a priori collaborating with or agreeing on terms with, something like a labeled property graph might be fine. But if you really care about what things mean and what consistent meaning across, a large organization with many business units, or kind of a scientific field with lots of people who aren't necessarily collaborating, they're at different universities, they have different setups, but they kind of want to be able to peer review each other's things and be able to reproduce and reuse each other's work in meaningful ways without too much human intervention. Then I think, semantic graphs are you kind of, I think the phrase by Jim Hendler from a while back was, a little semantics goes a long way. Just the idea that if you put in a bit more discipline in having persistent URLs for things, then you can go a lot farther, and you might not have as much initial velocity as you do with a property graph. I think Neo4j is great when you kind of want to get an app out and have a database that supports it and have it out in a couple months. But if you want something that you can kind of build on, and which I see a lot in the work that I do with scientists and academia and government, funding agencies want things that are going to be infrastructure essentially. Then there's a bit more of a attraction towards this semantic approach. But again, lots of similarities, and they both kind of.
I like the idea of keeping it in my head as a sticky note, because then I sort of, in my head, I made this analogy of, having a comment in my code of like, this is kind of what it does, versus having like a test or an explicit, like assert functions or something like that. Whereas, one is a bit hand wavy and a bit how I'm feeling that day, and the other one is like, no, this is explicitly how it works.
Yeah, absolutely. And there are certainly ways of just adding notes in semantic graphs. You could certainly add labels and comments to things, but they're part of the graph, and they can be, rather than kind of being like almost second class, or I don't know how to really put it, but something that's not quite part of your graph analysis.
Cool. So where is, where's linked data and the RDF and all this kind of thing being used? Are there any projects where it's sort of really taken off, or, actually that's it. Are there any projects where it's really taken off and it's kind of, saved the day?
Yeah. I think one of the big the big projects that a lot of people talk about and use an example is the Google Knowledge Graph project. So there is like a large database that they bought a while ago that used this semantic linked data technology, and they've essentially used that, and it started in 2012, but it's since been gaining steam. But essentially, rather than on Google, when you search for something, rather than only returning a sea of links, because Google has this semantic graph of things and what they mean, it's able to give you information boxes and contextual results. So you might have a Google search and not just see a sea of links, but you might see an actual answer for something, or you might see a box on the side when you search for a certain person or thing, and it kind of assembles a bunch of facts about that thing, person, place, or thing on the side. And so you won't necessarily have to click through to a page, because rather than the prior focus of being a web of documents, now because Google's built this semantic graph and they have this web of data, they're able to kind of given some contextual clues of your search, they're able to pull from all this data and put together in for you this amalgam, this structure of data that might be helpful to you, and it has been helpful to me. And part of that is because the data isn't necessarily pre-structured. It's kind of in this the smallest possible unit of these triples of statement, subject, predicate, object, and those can be assembled. And so the Google search is powered by this technology. Other things like the Facebook's open social graph and LinkedIn's connections, these things are powered in large part by semantic technologies, and so that's kind of been a big thing, and a lot of let's see, in terms of an open thing that people can look at. So we know about the Wikipedia project. That's kind of people compiling documents and stuff. So there's also been a project called DBpedia that kind of extracts all of the stuff on the info boxes on the sides of Wikipedia pages, all that structured data, and makes that available. And so a lot of projects have been using that, and a lot of companies will use that to generate machine learning models, because you kind of have this large corpus of data that's actually structured, apart from doing natural language processing on the main thing. Wikimedia, the parent of Wikipedia, has also started this project called Wikidata, that is essentially this. It's a large semantic graph where anyone can contribute, just like they contribute to Wikipedia. And I think it's sort of in a similar stage, maybe in some circles, as to what Wikipedia was when it first came out. It's sort of like, well, can we trust this? Like, anyone can edit it. Who knows? Whereas now, I think just because it's the thing that so many people have contributed to, and there are a lot of eyes on it, makes all bugs shallow, so to speak. People use it as an authoritative source a lot of times, or to be really informative as sort of a first step of their primary research. And I think that's probably where Wikidata is heading, where you can do these search Sparkle query on top of the Wiki database, and do a lot of things based on that. So I know there are a lot of projects in pharmaceuticals and in finance, different industries that are using this technology essentially in order to get a lot of these open data sets that are published in the so-called linked open data cloud. So that's a term one can search for and see, linked data sets that are open. And a lot of people are using that. So I think one thing to note is that linked data doesn't necessarily mean open. It just means that it's using web technologies to link things. So just like a company can have an internal intranet and use authentication, have like behind their firewall, they still, use browsers and web servers to like get real work done, but that doesn't necessarily mean anyone on the internet can access it. I think the same goes for linked data, where there's this real advantage that a lot of companies see and have used. Again, with the Google knowledge graph isn't open, but it's very helpful for them. The same thing with the LinkedIn graph and Facebook graph. But building on top of web technologies, they're able to get a lot of value and integrate a lot of disparate data sets. And as they get new things coming in, they're able to integrate it again using web technology. I think that's the key, is that you're able to abstract. You're able to get away from any parochialisms of any individual thing. So rather than having your whole knowledge structure be based on Python classes or Java classes, and so if someone's using a different programming language, forget it, because they're using URLs. That's sort of like the lingua franca of being able to kind of exchange data and information and meaning, because any library can speak HTTP, can get a URL, can get a response, can interpret a link. So
do you have these technologies, like what you have now with the Open API spec that I'm like, always talking about and following and on, where with the Open API spec, it has this series of generators. So like, I don't even really know that much, like what is in the original Open API spec. What I care about is that then I can compile it or generate it or whatever it's called down to Python, and it generates like, the classes and the typing and the documentation. It'll even generate some tests and things for me. Is there anything like that with linked data so far, or is that still kind of coming on?
Yeah, there is. So there have been a couple of standards that have helped with that stuff. In building on top of it, essentially vocabulary. So at a given URL, you might have a list of terms that are kind of like the last parts of the paths of that URL, and that kind of defines a certain set. And people have worked on things. So for one, there's this standard called SHACL, which stands for Shapes Constraint Language, and that's a URL, and there are certain terms within SHACL, and that's something equivalent to being able to close off a data set, like with JSON schema or SQL, where you can have these shapes of subgraphs and say like, okay, this thing, I want you to validate this data and come and see, like, is this something that has these properties, where this property fits this regular expression, and this is a positive integer, and this. So you're kind of like seeing if it fits this constraint. And so often, if things do fit that constraint and they validate it, then there are also tools and libraries that will generate, say, forms and displays. So you can display a website, generate HTML of your data. That essentially, well, if it's an enumerated value and you want to enter that, it'll generate a drop-down form. If it's a number, it'll use an HTML input number form. If it's a password, it'll use the password thing so you don't see it when you type into it. So you can do these things like HTML form generation, based on this SHACL language. Again,
that is very cool.
Yeah.
Every time I go to do anything in HTML, I'm like, why doesn't this already exist? Like, why do I have to build like a web page ever? Why isn't it just, I know it's so easy for me to say that from my point of view of like, I don't do any web technology. Why aren't you people doing it so much better? But yeah, I do always kind of wonder, why isn't it already like this? Why do you have to build out your HTML forms for absolutely everything? It seems like if you already have a documented data structure. So that's nice. I'm glad to know that. I will have to go look into it for that very reason.
Yeah, and the thing is, I mean, there have been lots of solutions about that in different domains for many years. Like for example, like I know if you use Python and use the Django web framework, there are these Django forms that, again, like based on writing Python code, Python classes, it can generate those forms for you. If you're in the Ruby world, there's Ruby on Rails, where if you write Ruby code in that framework, it will generate the HTML forms for you. But again, it's all sort of in your individual little things in your individual language. Whereas the idea of linked data is just you have URLs, and you can use this shapes constraint language based on your data. And the hope is, there can be an adapter for Ruby or Python or Java or Go or anything else, because you're kind of using this lingua franca. And yeah, so Shackle is one example, and there are a couple of other vocabularies. There's one called RDFS, which is very foundational, RDF schema, and it allows you to do that sort of thing. There's OWL, which is the web ontology language, but it gets easier to say OWL rather than WAL, but web ontology language. And one tool I've been using for that, which is nice, if you have an ontology that kind of describes all of your terms and what they mean, there's a tool called LODE. Gosh, I forget what it stands for, but there's also a Python version, Pyload, and essentially, given an ontology, it will generate a nice, shiny HTML page for you that has colors and like it documents everything, so you don't have to write up that part. I guess it's similar in code if you kind of have something that will auto-generate documentation from your Python doc strings or something like that. So yeah, there's a bunch of tooling about, given this discipline of I've used these URLs from these namespaces, like, oh, I'm using Shackle URLs. I'm not just saying, I'm not inventing my own URL to say like, oh, this should fit this regex. This field should fit this regex. I'm using from the Shackle namespace, from that URL, from that w3c.org, URL, that sense of regex, and a Shackle processor program will know what to do with that. An OWL processor will know what to do with that. So that's sort of the nice thing about that is you can kind of have this decoupling of people setting URLs and other people generating tools around them that assume those exact concepts by those exact names. So yeah, there are a few nice things about that in terms of validation and data definition and ecosystem.
That is very interesting. So tell me more about this project. The one that I put it in the comments that I'm not totally sure where and how they show up, but I will also put it in the show notes. So you have a GitHub project that's the intro to LinkedIn data with MongoDB and Python, and then you also have a YouTube playlist with a course that you created. What was kind of the inspiration or motivation behind going through and creating this?
Yeah, so that linked data course, I guess I wanted to bring it down in an accessible way to people who have maybe heard about it, maybe not, who are familiar with Python in this case, and who want to know about this technique or are curious about it. About managing data, particularly researchers who want to share data and not have to have everyone come back to them and ask them how to interpret it, and to not worry about whether people will reuse it, because they just don't understand the data. And so how can you possibly include context with data? And I kind of wanted to emphasize that for people who are familiar with Python and who are familiar with JSON and doing things programmatically, but how can you leverage this self-descriptive approach to data and be able to publish data that again is maybe more amenable to machine learning or analysis, or other people reusing it because they can more readily understand what it means unambiguously without you having to write up a README file and someone having to understand it and emailing you about it. And the README gets separated from the data. And so if you publish something on Zenodo or Figshare or something as like a JSON dump, it should kind of have everything that you need. And ideally it interoperates with other things. If people are getting your data and they're getting data from a few other sources, they sort of don't want to do any special work on interpreting your data and like munging it into format that they can actually use. And I wanted to show that it's the ability to do this is closer than a lot of people realize. I think that a lot of the documentation of linked data and semantic web, things can appear a little intimidating. They're very, long specifications. And the thing that I love about linked data, just in terms of research, is about thinking big in terms of how knowledge can be integrated and interoperated, and we can progress, through science and research and knowledge acquisition, without having to redo all these costly experiments. And so what I like about it is there's a sense of thinking big and not being afraid to think big. But I do believe that you can not only think big, but you can start small. You don't have to boil the ocean while you're doing it. And so that's really what I wanted to emphasize with this course. I wanted to have like a very small data set and be able to say, look, there are these Python tools you can use today. I'm going to walk through in a notebook with you. I'm not going to, give you PowerPoint slides or just talk at you and pretend like it's fine. But then when you go and do it yourself, you're like, oh gosh, this is like a lot harder than I thought it would be. So you actually see me walking through a notebook, and in the GitHub repo, I have like the dependencies. You can pip install things, and you can actually see the workflow of working with linked data, me explaining what it is, what we're looking at, and how to get it particularly into a form that you're maybe more comfortable with. So if you encounter this linked data in the wild and you want to, reuse it and support it because it supports all these nice semantics, so you can actually understand it, but your workflow is like, I need this as JSON.
And then it all breaks down.
Right. And so I kind of wanted to show that like exactly how to do that. Sort of take a linked data source, a published linked data source from nobelprize.org publishes all their data as linked data, and how to, get a JSON collection from that using Python tools and use, a technology you might use in a web app like MongoDB. Because if you're more used to like kind of a document centric search where I have a collection of JSON documents similar to SQL, I have a bunch of rows of tables like that. That's what I understand versus like a graph. How do I do a graph search? I don't know. And so you can take that graph and you can frame subsets of that graph and subgraphs essentially, and frame them as documents, and that kind of works for you. And now you have you're in document land, and you can do things as before. And I don't go over the reverse, but the tools are the same, where instead of framing something, you can have documents and you can flatten them. So instead of there being their hierarchical form, you flatten them into just the triples of the graph, and you can put them directly back in the graph. And I wanted people to see that was accessible to them if they know some Python, if they understand JSON. So there are 6 lessons. It's under 2 hours. I wanted things to be even shorter, but I figured it's fine. I kind of drone on for a little bit and try to explain things as I'm going. And so I just hope this
droning on, it's giving context.
Right, giving context. And so I just hope that it'll be helpful for people to dip their toes into this field and to feel like it's a bit more accessible to them, and it might have some benefits for them for the longevity of their data. So especially people who are publishing data and like maybe doing dissertations or doing research and want their data to be used and contribute to humanity's global growing knowledge base, that they're publishing in a way that that someone could discover this years from now, or maybe themselves years from now, and be like, I want to build on work that I did. Like, oh, I already did this, and be able to repick it up easily because you've left yourself all of these nice breadcrumbs. Yeah, so that's kind of the idea of the course, is to kind of get people feeling okay about it and feeling like it might not be as hard if they had heard about it, or if they hadn't heard about it, just to discover something interesting about using the web for representing data. Because people already know, okay, web for documents, web apps, but like how, there's the web and there's my data. Now those are separate things, and I'm trying to help people understand that just like the web can help us distribute documents all across the world to people, and like, or just media of any type, streaming video, audio, like we can do that with data too, over the web, using web technology. And it can be done. It can be very helpful for collectively us being able to solve world problems together as researchers, or in large organizations where you kind of, how do you talk to people?
Yeah, I don't know, this is just such an interesting use case to me, because to me, the most interesting problems aren't so much the tech problems, they're the people problems. How do we communicate with one another? How do we make sure everybody's kind of on the same page? How do we, create these standards that can make it, so that everybody can get along and have, at least a basis for talking to each other. So I really like it when these kind of tools come up. Are you using it on any projects currently that you can talk about, or not so much right now?
I can talk about a little bit. So I mean, like one kind of open project that I'm working on is this working group, an organization I'm with called the Materials Research Data Alliance, and we're trying to build a tutorial to help researchers in material science be able to publish data as linked data, essentially to increase interoperability among data sets. So to kind of reduce the amount of time that people spend finding, accessing, making interoperable, and reusing other people's data, which is kind of par for the course in research. You often, if you want to publish something novel, you need to demonstrate that it's different than what's come before. And a reviewer might say like, well, this seems very similar to this, or like, how does it compare to that? And so you often need to figure out what's similar semantically to what you're proposing. And if there are any previous data sets, you kind of want to get those and compare them and plot against them and benchmark them. So you want to work with this old data. And the data sets that tend to be used and cited for these sorts of things tend to be the ones that are easier to reuse, because people have limited time. And so I feel like researchers are a bit more likely to be cited and to have an impact in their career if they kind of make their published data machine actionable in this way. And so I have a lot of experience with the material science community, and so I've been working with them to publish a few data sets as this. Apart from that, yeah, I guess there's something that I guess I shouldn't talk about it yet, but a large federal agency that we've all heard of has an interest in connecting researchers across the domain, and not only the different researchers, but their interests and what they're appropriate at, and what they're competent at, what they're good at, essentially in order to foster collaboration and progress. So you might have someone in the building next to you, or in another site of the same federal organization that is an expert at this one measurement technique, but you don't know that, but you need that measurement to be done, and so to have this like semantic graph that has, where the digital assets are not just data sets, but they're also people and skill sets, institutions. I guess this is similar to the LinkedIn use case, where with LinkedIn is sort of a commercial way of like, you'll have people and they'll have skills, and you'll have endorsements for skills, and this is how recruiters can kind of find people that they think
they're really pushing that lately. Have you noticed? Like, I keep getting emails, oh, take our certification so that you can have this badge and like this thing, and I'm like, I don't even do that thing. I don't want a badge in that. Like, even if I was going to get a badge, I don't want it in this thing that you're telling me I should get it in. Yeah, okay, that's really interesting.
So I guess in a small sense, it'd be creating an internal LinkedIn for this federal organization to help people connect internally to each other, and not have to go to LinkedIn to do that. Because they have access to more privileged, security clearancy information. But that kind of use case. So that's another thing. And yeah, and then another thing. I guess I shouldn't talk about it too much. I can talk about it.
Remember, this is live. You don't want to get yourself in trouble.
No. It's just something I'm excited about. So it's R&D, but I'm working on this this microbiome, open microbiome collaborative project, and I've been helping people with the infrastructure with that, and I've been to sort of get people up and started. I've been using MongoDB for a lot of the backend for the data, and there is a semantic basis, a linked data basis behind a lot of this stuff, but we really aren't exploiting that. So we have a lot of nice ontologists on the team and a schema, but we sort of aren't really using a linked data approach to the actual publishing. And I'm excited about getting to that, either with Mongo and JSON LD, or there's this other technology that I'm excited about called Terminus DB. It's an open source graph database that uses linked data technology under the hood, and I think can be helpful with this sort of thing about collaborating on data. Again, because we're sort of aggregating lots of different data sets created by lots of different researchers, and essentially trying to provide a US national resource where people don't have to apply for grant funding to do the same experiments over and over again. They can see like, oh, this has already been done. I can actually reuse this stuff. I can pull in data across different domains that I might not necessarily be an expert in. I might not necessarily be an expert in proteomics or metabolomics, the different, catalysis activity across organisms. I might just be a metagenome person. I know about genomics and sequencers, but I don't know about protein activity. But I can access this other data and cross-reference it with my microbiome, and to learn about what activity is happening here, that its implications for human health, and that sort of thing. So really just a giant data integration and metadata integration project, and metadata enrichment project that I think semantic graph approach is really, I can't see another way to do it that makes sense to me. And I think the tools are kind of ready for that sort of thing to happen. And so I've sort of been pushing for that. So that's another thing I'm working on. Yeah, I'm
That'll
very,
be really neat. That's right up my alley. I'm going to follow that one.
Yeah, I'm hopeful about the future of this stuff. It's sort of similar to artificial intelligence had kind of like a hype cycle for a while, and then there was the so-called AI winter when it kind of fell short of its promises, and that's because computation, the techniques weren't quite there yet. But now it's sort of had a resurgence with deep learning and those sorts of things, and it's maybe people are thinking it's maybe a little bit too hyped again, but it's definitely had a resurgence because different technologies and infrastructure have come together to make it actually really strong in a lot of applications. And I think there's a similar thing for linked data. So a lot of the excitement about it, there was an original Scientific American article in 2000 with Tim Berners-Lee and Aurel Asila and Jim Hendler. And there's a lot of promise about it, and standards were developed. And I think there was maybe an initial hype cycle, and people got a little bit disillusioned with it. But since then, standards have come into play, and things have gotten a bit more mature. Schema.org has come into play. That's a big application of linked data where lots of web people are marking up their web pages specifically because they want to get better Google results. So they're using a lot of linked data from the schema.org vocabulary. And that's just a vocabulary, just like OWL is a vocabulary, RDFS, Shackle that I mentioned. Schema.org is just another domain that has a bunch of URLs that mean things. And so people have done a lot of great stuff with that. And new standards have come out in the last few years about, as I mentioned, JSON LD and about Shackle. Validation was missing for a while. So I feel like there's some maturity that's coming back to this linked data landscape, in part because of the success of large companies using the technology like Google and Microsoft through LinkedIn and Amazon as well. I forgot to mention, but they definitely use a lot of semantic technology under the hood. They've actually recently commercialized. They bought a big semantic web company and released the Apache Neptune graph database that again allows you to query semantic graphs using Sparkle, and they also allow linked property graphs. So again, there's been a big resurgence in this sort of technology and infrastructure, and I think good things are happening. and I'm excited to be involved.
I think good things are happening too. And, just to go back to a point you were talking about a little while ago, I think it's so important to, to support research and making sure that we're doing as much as we can to make sure that the research is accessible and reproducible. And a big part of that is being able to publish your data. So, I think that's also a really important point for people to consider as well, which I know it used to be so difficult, if nothing else, just simply because of storage. Like, where were you going to store this data and put it and make it publicly accessible? I think we've kind of gotten over that hurdle a lot for the most part. Storage is pretty cheap these days, but now we have, this sort of additional layer of, well, how do we make the data accessible to people? And yeah, and I really like this idea of, having these different vocabularies and semantic graphs and things. So that's really neat. Did you have anything else you wanted to bring up about the project before we call it time?
I guess I'll just say that it's openly available. I guess it'll be in the show notes. Intro to linked data with Python, and there are 6 episodes, and there's a link to the YouTube playlist. And I encourage you all, dear listener, to watch and to send me any feedback. This is kind of the first iteration of the course. I'd love any feedback on it, and I'd be interested to hear how you're using linked data as a data scientist, just how things are going with that. So just want to emphasize that it's completely free, as in speech and as in beer. So enjoy the course. Thank you.
Cool, great. I was thinking we should do a quick, blurb about any cool projects we're working on and to keep an eye out for. And then I keep forgetting to talk about it, and I feel like I'm putting you guys on the spot. But what the hell? Since I keep forgetting about it, and here we are. Do you have any other cool projects to talk about, or did we already go over all of them?
Oh, well, I mean, I guess there are a couple of projects I have, but I don't know if they're at the stage to be talked about. But one of the things that's specifically related to linked data is I think still a lot of people have trouble with just actually minting URLs and hosting things. You mentioned, data sets. It's easier to sort of publish things to public archives, and a lot of people have that. But I think similar to the way that a lot of people just with the document web, people generally, there's a whole ecosystem around. You can go to places like, I don't know, Squarespace, or or the original kind of was GoDaddy, where you can kind of get a domain name, get your domain up, and there are various ways of doing that. And a lot of people now might do things like LinkedIn pages or Facebook pages, and that's how they kind of get their content on the web. And so I think still people are there's not quite a nice go-to, particularly among all domains, for how to get your linked data up on the web. And if you have terminology, a data dictionary of terms that you want, how do you get URLs for those terms and host them stably? And I think that's not a solved problem. And so I've been working on a project to kind of help with that, to kind of help people mint their URLs and store them persistently. And just as a project, I'll give a shout out to the ARK project. ARK stands for Archival Resource Key. It's a nice protocol and specification for separating what they term name assigning authorities and name mapping authorities. So to have a culture institution be able to have a unique ID similar to a DOI prefix, where they're able to assign their names, but they're actually able to delegate to another organization, a service organization, just like someone can host your website, to someone to actually host the names and actually map the names and make them resolvable as URLs. So this ARK specification is kind of nice for that kind of thing. I really like that project, and the sort of the big example of that project homepage for it is name to thing. So if you go to n2t.net, name to thing, or just look up ARK's ARK Archival Resource Key, you'll find more about this protocol and ecosystem about helping people to give names to things and helping them to be hosted persistently. without them necessarily having to have the resources to do that, and then being able to dispatch, just like you have your website maybe hosted on AWS instead of a box under your desk. Again, you can be responsible for naming things, but not necessarily name mapping and making things persistent on the web as part of a linked data web. So yeah, that's another project I'll call out to.
Cool. Well, we'll be sure to link to ARCs, and what was the other one?
I guess ARCs, and I guess the project would be N2T, named a thing. It's kind of an example of
Okay. Yeah. So we'll be sure to link to those in the show notes.
Yeah. Okay. Great.
Cool. All right. Well, I think we're all done for the week. So we're going to be taking a break for Christmas, and because Donnie's having a baby, and I'm very excited about Baby Watch. So I don't know. I think we'll probably be back sometime around the new year, or maybe a little bit later, depending on where we're all at. So bye-bye. Talk to you next year.
Bye.
Bye.